Welcome to this channel, Tech Explained by a Real Expert. I'm a software engineer with nearly 20 years of experience, here to make tech simple and accessible for everyone. From expert insights and honest reviews to practical tutorials and the latest tech news, it's all right here. Subscribe for smart, reliable tech content. Like the videos to show support. Comment to share your thoughts or request future topics. Let's build a strong, informed tech community together.
What is quantum physics? Quantum physics, or quantum mechanics, is the branch of physics that deals with the behavior of matter and energy at the smallest scale at the atomic and subatomic level. At these tiny scales, particles like electrons, photons, and quarks don't behave in the same way that larger objects, like baseballs or cars, do. Instead, they follow different, often non-intuitive rules, which include 1. Wave-particle duality. Particles can act like both particles and waves. 2. Uncertainty principle. We can't know both the exact position and momentum of a particle at the same time. 3. Quantum superposition. Particles can exist in multiple states at once until measured. 4. Entanglement. Two particles can be linked in such a way that the state of one affects the state of the other, no matter how far apart they are. While these principles seem strange, they are fundamentally important in explaining the world at microscopic scales and have paved the way for many breakthroughs in technology. Real-world applications of quantum physics. Though quantum physics can seem abstract, it has practical and transformative effects in modern technology. Here's a deeper dive into how these quantum principles shape our world. 1. Semiconductors and electronics. Modern electronics are built on semiconductors, which are materials that can control the flow of electricity. The functioning of these semiconductors is heavily based on quantum mechanics. Transistors, the fundamental building blocks of all modern electronic devices, rely on quantum principles to control the flow of electrons. These tiny switches, transistors, are what allow computers to perform complex calculations and run programs. In a quantum world, electrons exist in discrete energy levels, and their movement between these levels determines whether a transistor is on or off. This principle of quantization allows semiconductors to process digital information efficiently. Every smartphone, computer, and gadget that uses microchips owes its existence to quantum physics. The miniaturization of these devices, which has been central to the information age, is a direct result of our understanding of quantum mechanics and how we manipulate particles at tiny scales. 2. Lasers. Lasers, light amplification by stimulated emission of radiation, are another amazing product of quantum physics. A laser works because of a quantum principle called stimulated emission, where electrons and atoms can release energy in the form of light when they drop to lower energy levels. Lasers are widely used in industries ranging from medicine, for surgeries like eye corrections, to communications, fiber optics, to entertainment, laser shows, DVD players. In particular, the coherent light produced by lasers light waves that are perfectly aligned is a quantum effect that allows lasers to be focused with precision. 3. Magnetic resonance imaging, MRI technology, a key medical tool for diagnosing conditions inside the human body, is based on the quantum behavior of atomic nuclei, specifically hydrogen nuclei, protons. Quantum spin and nuclear magnetic resonance, NMR, play an important role in MRI. When placed in a magnetic field, the protons in the body align and rotate in a predictable way. This allows MRI machines to produce high-resolution images of the inside of the body. MRI technology is one of the most important diagnostic tools in modern medicine, allowing doctors to visualize soft tissues, organs, and the brain in non-invasive ways. 4. Quantum cryptography and security. One of the most exciting and futuristic applications of quantum mechanics is in the field of quantum cryptography. Cryptography is the science of securing information, and quantum mechanics offers a way to achieve unbreakable encryption. Quantum key distribution, QKD, relies on quantum entanglement and superposition to securely share encryption keys between two parties. Any attempt to intercept the communication would disturb the quantum state, making eavesdropping detectable. This kind of quantum encryption could revolutionize the way we protect sensitive data, from bank transactions to military communications, making hacking and data theft much more difficult. 5. Global Positioning System, GPS. The Global Positioning System, GPS, which helps you navigate your way around the world, depends on extremely precise atomic clocks and atomic clocks work thanks to quantum mechanics. GPS satellites use cesium or rubidium atomic clocks, which are based on quantum transitions in atoms. These clocks are super precise and can measure time to within nanoseconds, enabling GPS systems to pinpoint locations with incredible accuracy. The reason your GPS can tell you your location on Earth with such precision is because of quantum mechanics' role in time measurement. 6. Quantum dots in displays. Quantum dots are nanoscale semiconductor particles that are used to improve the quality of displays, such as LED TVs and smartphones. These quantum dots emit specific colors when light is shined on them, thanks to quantum effects. The size of the quantum dot determines the color it emits. The result is vibrant, high-quality displays with better color accuracy, higher brightness, and more efficient energy use. These displays are found in many high-end television screens and smartphones. 7. Superconductors and magnetic levitation. Superconductors are materials that, at extremely low temperatures, can conduct electricity without any resistance. This phenomenon is a direct consequence of quantum mechanics. Magnetic levitation, maglev trains, which float above their tracks using powerful magnets, are made possible by superconductors. The quantum properties of superconductivity allow for the creation of powerful magnetic fields that enable frictionless movement. Superconductors are also used in MRI machines, particle accelerators, and are expected to play a key role in future energy transmission technologies. 8. Quantum computing, the next frontier. Quantum computers are still in development, but they promise to revolutionize the way we process information. Unlike classical computers, which use bits, 0 or 1, quantum computers use qubits, which can exist in superposition both 0 and 1 at the same time. This allows quantum computers to perform parallel calculations, exponentially speeding up tasks like simulating chemical reactions, solving complex optimization problems, or breaking traditional encryption. Quantum algorithms could also aid in fields such as artificial intelligence, cryptography, drug design, and climate modeling. Quantum computing holds the potential to solve problems that are currently intractable for classical computers. Conclusion: the quantum revolution. Quantum mechanics is no longer just an abstract theory confined to laboratory, as it is at the heart of many technologies that we rely on every day. From the tiny transistors in our smartphones to the vast networks of GPS satellites, quantum physics is fundamentally shaping our world. Looking ahead, as quantum technologies continue to develop, we're likely to see even more groundbreaking applications, from quantum computers that could change how we process data, to quantum-secured communication systems that could make digital hacking nearly impossible. While quantum mechanics still defies some of our intuition, it is undoubtedly one of the most influential and transformative areas of science, and its impact on society is only set to grow. Everyday tech and convenience. Most of the devices we interact with daily, from smartphones to computers to medical devices, depend on quantum physics in ways that we don't even realize. For example, semiconductors' quantum mechanics is the backbone of the transistors in computer chips. Without quantum principles like energy quantization and electron movement, we wouldn't have the miniaturized electronics that power our gadgets. GPS. Every time you use a GPS app for directions, you're tapping into atomic clocks that measure time using quantum principles. These clocks allow the satellites to determine your precise position on Earth with incredible accuracy. Revolutionizing medicine. Quantum physics plays a significant role in medical diagnostics and treatment. MRI machines, MRI technology, which relies on nuclear magnetic resonance, NMR, and the quantum spin of protons, allows doctors to get high-resolution images of organs and tissues. This technology is one of the primary ways we diagnose serious health conditions, like cancers, brain disorders, and joint problems. Laser surgery. Lasers, which are based on quantum principles of light emission, are used in a wide range of medical treatments, from eye surgery, like LASIK, to tumor removal. Their precision and efficiency have dramatically improved surgery outcomes. Security and privacy. One of the more futuristic but incredibly important developments in quantum physics is quantum cryptography. Unbreakable encryption. Quantum mechanics enables the creation of quantum keys for secure communication. This technology can secure sensitive data by exploiting quantum properties like entanglement. If someone tries to intercept the communication, the quantum state would change, alerting the sender and receiver. Data protection. As hackers get more sophisticated, quantum encryption will be critical for securing everything from banking transactions to personal information to military communications. It's a potential game-changer in the fight against cybercrime. Energy and sustainability. Quantum mechanics isn't just for high-tech gadgets, it also has the potential to help address energy challenges. Superconductivity. Superconductors allow electricity to flow with zero resistance, which could drastically reduce energy waste. Quantum properties of certain materials at very low temperatures enable this. In the future, superconductors could be used for energy transmission over long distances without energy loss, improving the efficiency of power grids. Quantum dots for solar energy. Researchers are exploring the use of quantum dots to increase the efficiency of solar cells. These tiny semiconductor-based materials can be engineered to absorb a broader range of light frequencies, improving solar energy conversion and helping in the fight against climate change. Next-generation computing and AI. One of the most exciting and still developing applications of quantum mechanics is in the realm of quantum computing. Speed and power. Quantum computers promise to solve problems that classical computers can't, problems involving huge datasets, complex simulations, and optimization. For example, they could dramatically speed up processes in drug discovery, climate modeling, and even artificial intelligence, AI. Artificial intelligence, AI systems could become exponentially more powerful when combined with quantum computing. Quantum algorithms may help AI learn faster, optimize more efficiently, and tackle problems like pattern recognition or data analysis that take traditional computers much longer to process. Everyday impact, from entertainment to communication. Quantum dots and displays. If you've bought a high-definition TV or a smartphone with a vivid display, you might be using quantum dots that help improve the picture quality. These tiny quantum particles emit light of specific wavelengths, creating better colors and brightness. Fiber optic communication. Quantum entanglement is being explored for its potential to revolutionize the speed and security of internet communications. Imagine data transmission that's instantaneous and unhackable, which could make the internet not only faster but more secure against cyber attacks. Society's growing understanding of quantum tech. The everyday use of quantum-based technologies is helping society better appreciate the strange but powerful forces that govern the quantum world. As quantum technologies mature, we can expect them to revolutionize the job market. Industries in quantum computing, quantum encryption, and quantum sensors are already creating new career paths. Engineers, researchers, and data scientists will be at the forefront of innovations that involve quantum technologies. Ethical and legal questions. As technologies like quantum encryption and quantum computing change how we think about privacy and security, society will need to grapple with questions around data rights, encryption laws, and ethical boundaries in quantum applications. What happens if we can decrypt all data instantly, or if AI-powered quantum computers can design new weapons or disease cures? The future, quantum impact beyond our imagination. Though quantum mechanics already has a significant impact on our daily lives, the potential future applications are even more mind-blowing. Quantum medicine. Quantum technologies could lead to more precise diagnostics, new drugs, and even quantum sensors that can detect diseases or health conditions earlier than ever before. Think about quantum-enhanced imaging that could let doctors see cellular activity at the molecular level. Smart cities and infrastructure. Quantum sensors could be used in smart cities to monitor infrastructure, traffic, pollution, and even weather patterns with much greater precision. This could help improve energy efficiency, reduce waste, and make urban living more sustainable. Conclusion. Quantum physics is already shaping our lives. At first glance, quantum mechanics might seem like a distant field with little relevance to daily life. But, as we've seen, its principles are the foundation of everyday technologies, from the electronics in your pocket to the GPS system, guiding your way to medical advancements that save lives. And this is just the beginning. As the technology around quantum computing, quantum cryptography, and quantum sensing continues to develop, we are on the brink of another technological revolution, one that could redefine industries, change how we live, and possibly even challenge our understanding of reality itself. The power of quantum physics lies in its unpredictability and potential. Its strange rules may seem hard to grasp, but they're already embedded in the fabric of our modern world. The more we unlock its mysteries, the more we stand to gain.
Thanks for watching. I really appreciate you taking the time to check out my video. If you enjoyed it, don't forget to like, comment, and subscribe for more content. Your support means the world to me and helps the channel grow. Stay tuned for more videos, and let me know in the comments what you'd like to see next. See you in the next one.